Hello everyone, this is Abhishek Gaire and my teammates are Samir Bhandari and Sachin Bista. Our project title is Real-Time Analysis of Stock Price Based on Technical Indicators and Investor Sentiment using Deep Neural Network, and we are guided by Dr. Guru Vimal Kumar. He is an associate professor. So we will be talking about abstract, objective, introduction, literature review, design and methodologies, standards and policies used, implementation, testing, input and output demo video, conclusion, future enhancement, and so on. So coming to abstract, our project integrates deep neural network with technical indicators and sentiment analysis for real-time stock price prediction, evaluating historical data and sentiment indicators. Our model showcases superior accuracy, learning temporal dependencies effectively, and we use LSTM architecture, which which gives accuracy of 88%, and we also use random forest classifier and k nearest neighbor classifier. So coming on objective, our aim is to develop a real-time stock analysis system using deep neural networks to integrate technical indicators and investor sentiment. Our scope is to integrate diverse technical indicators like stochastic chart, Bollinger chart, and so on. Also implementing sentiment analysis algorithm from various sources and develop real-time analysis using deep neural network. So coming on introduction of our project, the system aims to enhance decision making of traders and investors by providing accurate predictions based on technical and sentiment analysis. It will focus on diverse technical indicators, sentiment analysis algorithms, and feature engineering techniques to handle large volume of data efficiently. So here are some of the literature review we refer on. So first one is transformer gated recurrent unit method for predicting social price based on news sentiment and technical indicators, which was published in 2023. They integrated news sentiment and technical indicators, and they exhibited enhanced prediction accuracy by demonstrating the effectiveness of combining textual data and technical indicators for forecasting. And on second, we have a portfolio selection strategy based on the peak of price involving randomness. It was also published in 2023. Their strategy-based peak price randomness offers a unique approach to optimize investment portfolios on certain market conditions. Their strategy displayed potential in improving portfolio performance by considering peak price factors. On third, we have hybrid information mixing module for stock movement prediction. So here they effectively integrated multiple sources of information to enhance prediction performance. Their approach showcased the potential of hybrid models in improving social price prediction accuracy. On fourth, we have a stock price prediction based on by LSTM and improved transformer. It was also published in 2023. So they improved transformer model, achieving superior prediction accuracy compared to traditional methods. And at last, we have stock price prediction model based on investor sentiment and optimized deep learning. They demonstrated improved prediction accuracy by incorporating sentiment analysis into their model. Their study emphasized the importance of considering investor sentiment in stock price forecasting. So coming on design and methodology, we have four modules: exploratory data analysis, technical analysis, sentiment analysis, and time series analysis. So in exploratory data analysis, we utilize Y Finance API to collect stock price data, including open, high, low, close, volume, and adjusted close. These are just the indicators where the stock price fluctuates on, and also focuses on adjusted close price for prediction of accumulated corporate actions. Exploring data structure and formatting, including sentiment indicators. And for descriptive statistics, we compute summary statistics like mean, covariance, correlation matrices, standard deviation, min-max values. and visualization distribution of stock price technical indicators and sentiment scores using histograms, box plots, and density plots. On technical analysis involves using charts indicator to identify trading signals and price signals. Common indicators include moving averages, MACD, stochastic oscillator, and RSI, which help analyze trends, momentum, volatility, and volume. And in sentiment analysis, we collect news from investing.com by web scraping using Selenium and Beautiful Swap. Also, we can use Google Pi News, and there are many more like that. And in sentiment analysis, we perform sentiment analysis using NLP tools like NLTK Weather and TextWork to obtain sentiment scores. Combining sentiment analysis results with historical data price assess the impact of news sentiment on stock price direction. So we have algorithms which includes regression and classification, post stock market prediction as regression for price forecasting and classification for direction prediction, model selection, gradient descent based, and optimization. Our fourth module is time series analysis. In time series, we utilize time series data to predict stock market trends and conduct augmented decay fuller ADF test to check for stationarity. And using this, we can know when the price of the stock has reached which point. So, on coming to standards and policies, we have a standard use ISO IEC 27001, which is widely recognized international standard for information security management systems, which is abbreviation of ICSMS. It provides a systematic approach to managing sensitive company information, ensuring in confidentiality, integrity, and availability. The standard outlines requirements for establishing, implementing, maintaining, and continually improving an ISMS within the context of the organization's overall business risks. So we have some of the diagram. This architecture diagram, so we have three components: data collection, feature engineering, and prediction engine. In data collection, we have three parts of collecting a data: historical price data, live market feeds, and news articles, which which will be later processed in data processing. And after processing the data are transferred in for to sentiment analysis and LSTM. So LSTM gathers the technical data and sentiment analysis gathers the news sentiment. And after processing LSTM and sentiment analysis, it goes to MOE, which is called as mixer of experts, which combines the data and it transfers it to prediction engine for price forecasting, and it is later shown to the user through the UI. And this is data flow diagram. It shows the way the data flows. You can see it clearly. And this use case diagram. There are three persons, three actors: investor, trader, and financial analyst. And this is the class diagram. This is the activity diagram. Your investor requests a prediction. If the data is available in the system, it goes to the data train model and generate forecast. If it is not, it gathers the data and it goes to the pre-processed data train model, generate a forecast, and at the end view forecast. And this is the sequence diagram. There are four in sequence diagram. There are four methods: investor, system, data manager, and prediction model. You can clearly see where the sequence of the data flows. This is the AR diagram. And coming on testing, we have unit testing, integration testing, system testing. And unit testing involves testing individual components or units of the system in isolation using specific test cases to ensure their proper functioning. This process ensures that each unit operates as expected. So in unit testing, we have done testing of RSI. And in integration testing, focus on testing the interaction of interfaces between different modules. In system testing, entails testing the entire system as a whole to verify it meets specified requirements and functions correctly in its intended environment. This is the test result after we have tested our project and model. This is the input and output. So here we have given the component name and it generated the news of the of that stock. This is the ADF test to calculate the statistics of that company, and it also shows the ACF plot. This is the candle chart of AGN company, and yeah, on the right hand side it is the sentiment analysis of that company. Here that's the pie chart of Tata Motors sentiment analysis, and it gives the idea whether to invest or not in the coming days. This is the demo video, and in conclusion, this paper introduced a groundbreaking stock price forecasting framework that combines LSTM and MOE to fuse technical indicators and sentiment data effectively. Experimental results showcased its superior predictive accuracy compared to LSTM and CNN models, addressing into limitations in existing literature. The framework's innovative incorporation of LSTM along with its holistic approach to combining sentiment analysis and sentiment analysis and technical indicators fills a crucial gap in the current research and offers a deeper understanding of market dynamics. So this is the future enhancement, which could involve integrating diverse data sources like earning, call transcripts, SSC filing, and web traffic matrices. Additionally, conducting comprehensive performance testing across different prediction origins and adjusting model complexity accordingly could enhance forecasting capabilities significantly. These are the web preferences. Yahoo Finance is for gathering the data, and second one is the journal. This is the Palestinian report, and this is the journal which we have published. This is the poster of our project, and this is the GitHub link. And these are some of the references which are referred. So the execution part will be continued by my teammate Sachin Bista.
Hi, my name is Sachin, and I am going to describe about the code and implementation part. In the in the coding part, we have three sections: technical analysis, sentiment analysis, and time series analysis. In the technical analysis, we have simple moving average and moving average convergence divergence. So first of all, we have to collect the data. For collecting data, we have collected data from Y Finance. Here the coding part for collecting the data, and then data collection of different companies like Adani, Geofinance, SBI Bank, etc. And this is how we collected the data: open price, high price, low price, and adjacent close price. Then after, we have to do the data analysis of the prices. Similarly, this is the adjusted close price for all the stocks. Adjusted close price means how much the price is ended in that date. Adjusted close price with different scales, and data transformation using the lambda function, and stock returns or stock profit through the different time periods. This is stock return for 6 year time period, and how much the percentage has changed, like how much difference is in the stock price in different time from 2019 to 2024. In the data collection, we have done the cleaning of not a value from the data. For the plot return for 2023, it is the graph for it. Similarly, the same as done for all the companies. This is annual returns of Adani Geo Finance Axis annual percent rate graph, and this one is a statistical data for return data from return. And here we have made the correlation map of different companies. So this one is this, and next we have the chart pattern for technical indicators like simple moving average. We have different chart patterns. Same import by finance data collection and visualizing the stock data. Candle chart is candle chart of candle chart of any one specific company is done here from January 2010 to 2024. Now we have to move to the simple moving average, which one is technical indicator. 20-day simple moving average for AstraZeneca stock. 20-day simple moving average means 20-day average days of 20. Similar 20, 50 and 200 days moving average for same company. We have get the open price, high price, low price and close price. This one is according to the regime value. We can see how or when we have to buy and when we have to sell. If the regime value is 1, we should buy, and in the regime value is -1, we can sell as shown here. And this one is exponential moving average. We will be calculating the exponential value, which will normalize the simple moving average. And this one is triple exponential moving average cost for AstraZeneca stock. Now let's go to the sentimental part. In sentimental analysis part, we have same data collection. Actually, sentiment part is done in the VS Code, so I'll be going to the VS Code ID. Here, first, as I said, we have to install different libraries as Panda, NumPy, PyPlot, Sklearn, and importing the data like which company we have to get the articles or news. Based on the news, we will be doing the sentiment analysis. As you can see, we have the different title of different news. Different date and published date and the news related news. Cleaning the news that we get. Here is the news. Removing the inline breaks from the text file, which will help to normalize the news articles. Uh, Here all the same process is done like classification and cleaning, and that at last we will be seeing the how the sentiment is classified on different classifier. Here we can see the confusion matrix of SVM classification and precision and recall value, accuracy, SGD classifier, and Kenaiver classifier. Here Kenaiver classifier is considered as the best, as the decreased value precision is 63% and increase is 28%. The last one is the time series analysis. In the time series analysis, we have your STM, which is the main algorithm used here, a deep learning algorithm. Same, we have done the same data input and data collection. adjusted close price for SBI stock, uh, collecting the area value of the different time period. This one is splitting the data into training part and uh, test part into x and y axis, area value, and building a LSTM with 15 neuron and 4 hidden layer. We have done 200 epochs of different 4 neurons, then predicted to 53 values using from the past 60 trend data, converting the data into NumPy array, which is 246 and 60, and calculating the RMSE value, which is root mean square error value. Error value less the error value means a best algorithm, and we have plot the predicted and actual value graph here using LSTM algorithm, and this one is the actual price. In the time series analysis, we have one more model, ARIMA model, which is auto-regressive integrated moving average model. Here we'll be decreasing the seasonality of the code. Here how we install the library, same as previous, importing the stock data upon any specific company. We get the high look and adjacent close value and the graph. Here we can see the seasonality graph of any one specific company. The seasonality property do not change over time, so it has a constant mean and variable. Time series stationary process is modeled in this ARIMA model, and ADF, the augmented decay theory, is the statistical test to determine if a time series is stationary or not. The ADF test is done in the ARIMA model to check whether the stationary is there in the model. We can see here ADF is being executed, and a graph of autocorrelation and adjusted close price. Differencing of the ADF is done. This is a differencing ones of the graph and autocorrelation after remove the stationary. Autocorrelation function is established here, and it's final, and the residual error is being taken out, and parameter is iterated through the model. A fitting model is given to the area model, and after grid search, finally a prediction is made from actual and predicted result. This one is the graph of forecasting and adjacent close graph. Predicted value is plotted here. Thank you.